Hi Professor, this is Jeff Sexton, and I'm going to run you through my Lesson 20 Literacy Test on Data Analysis. Okay, looking through here, we went through first our sketch of frequencies, so we went ahead and plotted out our distribution of our numbers in the data set that was given to us. We then created a wonderful distribution function that then equaled out to R1. From there we went into our histograms. From there, each box in the histogram will measure the probability that the data set is going to be plotted within that box. Oops, let me get back up there for my answers, and I'll include these in with my submission. For the two different data sets, we have our plot A's and plot B's that I labeled, so it'll be easy to read later. The expected value would be greater in plot A because all of the plots are going to be tied closely together around the 8. But then the greater variance would be in plot B, since the data set is going to be more spread out evenly amongst the available numbers. Again, we went into a couple of histogram questions. And we went into the cumulative distribution functions and said which is and which is not a cumulative distribution function. Cumulative distribution function must go ahead and progress up to 1, so we're not able to go ahead and dip back down, so this is not a correct graph. This one is a correct graph, as we can see it goes closely up to 1. Down here, again, we're going to go above 1, so we can't go above 100% of our total, so that's not going to be a correct way to describe a histogram function. Cumulative distribution, that is. From here, we're not going to be going down, we're going to be going up to go ahead and get ourselves up to 100% of all data. So that will not work. This one will not equal out to 100, so equals 0.7, so that doesn't work as well. This one, I believe, would work because we're going from 0 all the way up to 100, even though it's simple. It just means that there isn't very much variance in the numbers in the data. From here, I hand calculated the variance, and I'll go ahead and submit this to you as well. There's your expected value, and then there's your variance, 1.6. From here, on our next page here, we were talking about, again, variance. The elongated graph will have the greater variance than the one that has only a couple points that goes immediately up. We went through a couple different ideas on describing variance, and I'll go ahead and submit these to you as well. Taking the variance function from what we've been working with and go ahead and blowing that out with the expect x shown and not contracted, rather. Here's a couple data sets that were asked to be given to give a variance of 0. So if you have the same number, obviously you're not going to have a very big variance in those numbers. Likewise, I created the same thing, down a point, up a point to give the same variance. Okay, home stretch, here we come. We did a couple probability statistics. This was all derived based off of past homework assignments and past live math statistics, so I didn't do these ones by hand, but I used the computer to help me out with the calculations for me. Likewise, here is your calculation of getting a 7, of getting a 6. So we went ahead and drew those ones out. 6 out of 36, 5 out of 36, 13%. Going through here in the square root of the data set. This one was a little tricky, but I think I persevered through it. Knowing that on the square root of the data set that we had 5 different points, that we had 2 A's, 2 B's, and a C, so we knew that A was going to be 40% of the data set, B was 40% of the data set, and C was 20% of the data set. We then could go down here and say that, you know, in A, or rather in A is going to be 40% of the data set times the square root in your cumulative distribution function in live math. Likewise, here's your B is 40%, your C is 20%, so we went along with that metric. This one I skipped. Your A is 0.4 divided by 2 is 0.2 times your distribution function of the square root of x. What else do we have here? From here we did a couple live math questions by adding C's and different points within the function itself. If you add a C on the outside of the function set, it's not going to affect the outcome, but rather you can pump up the stat, if you will, after the calculation is complete, you add 3, 4, 5 to that calculation. It's just going to boost up all numbers within that set by 5. It's not going to really change the variance of that function since they're all going to be the same numbers. And what else do we have here? I believe that kind of sums it up. We then talked about multiplication of C, and we talked about the addition of C. Multiplication will go ahead and change some of the facts, but that's what's going to be considered within our variance function formula. Is going to be multiplied out and expanded. So that was a pretty quick rundown of the statistics in the literacy test. If you need further clarifications, let me know. I was trying to keep this one short and sweet for you. I'll upload, of course, this data into the portal as well as this video, so you'll have both to assess my literacy of the learned information. Thanks.